Hello guys, welcome to IB360. In this video we are going to solve an example problem from free force diagram. So if you haven't watched our videos on free force diagrams, there will be a link floating above you. Click that link, watch that videos, then come to this example problem. Your concepts will be cleared. Okay, so we just said, let's get started. Okay, so that means in this question they have given there is a block of mass m. Okay, so this is the block of mass m, and on the block of mass m there are two forces that are acting. The force acting at an angle theta and the force that is acting downwards. Okay, so we need to find the free force diagram. In any question, guys, in any question, if you follow the 4 steps that we discussed in the previous videos, you'll get the answer. Okay, so in the first step we have to classify which are the bodies, right? So that means the bodies will be the block of mass m, and the ground, right? So that means there will be the two bodies that will be present in our free force diagram, the block of mass m and the ground, right? So this was a step number 1 to identification of the bodies. Okay, what was a step number 2? Step number 2 was to isolate the bodies, right? So that means if I just isolate the bodies, okay, so that means if I isolate the block of mass m and the ground, what will happen? See, so that means this is the block of mass m. Isolating the bodies does not mean isolating the forces acting on the body. The forces will act in the way that they intended on the body. Okay, so that means we are just isolating the bodies, not the forces. So that means this is the force F downwards and this is the force F acting at an angle theta, and this is the ground, right? And this is the ground. Okay, so now we have successfully completed our step 2, that was isolating the bodies. Now what was step 3? We have to identify the surfaces in contact, right? So that means I can say that the lowermost section or the lowermost surface of the block of mass m, this is 1, is in contact with the uppermost surface of the block of the wall of the ground, right? Ground. Okay, so that means the lowermost surface of the block of mass m is in contact with the uppermost surface of the ground, right? So then what we used to do, used to form a box. So surface 1 and surface 2 are in contact, right? So then what will happen? Surface 1 will exert a force towards surface 2. Why? Because they two are in contact, and when they are in contact they will exert forces. Okay, so surface 1 will exert a force towards surface 2. The value of that force will be how much? N1. Okay, so that means in this direction surface 1 will exert a force N1. Similarly, surface 2, by the virtue of Newton's third law of motion, what will happen? Surface 2 will also exert the same force but in the opposite direction, right? So that means surface 2 will exert a force towards surface 1 in the opposite direction, and the value of that force will be N1. So that means over here this will be the direction of the force N1. Okay, are there any more surfaces in contact? No, there are no surfaces more in contact, right? So that means we have finished the portion of the contact forces. Now what will be the non-contact force acting on the body? The non-contact force will be the weight of the body, right? So the weight of the body is nothing but mg, which is acting downward, right? So that means we have successfully found the free force diagram. So that means the free force diagram of block M will be equal to, so this is the force F that is acting at an angle theta. Okay, so this is the force F that is acting downwards, and this is the weight of the body mg downward, and this is the, and this there will be the contact forces, right? So this will be the contact force N1, right? So but I don't want to leave this in this form. Okay, we know that forces can be resolved into x and y axis, right? So that means this force F can be resolved into x axis and y axis. See, so that means the force along the x axis will be Fx and the force along the y axis will be Fy, right? So I can write that from this triangle I can write cos theta will be what? This magnitude, that is, what is the magnitude? Fx divided by the hypotenuse, that is this magnitude, and what is this magnitude of the vector? F, right? So that means Fx by F. So that means our Fx will be how much? F cos theta, right? Similarly, I can write in this triangle sin theta is equal to how much? This height, right? That means Fy, height by hypotenuse, and what is the length of the hypotenuse? F, right? So that means from here I can write that Fy will be F sin theta, right? So which means that if I have a force F that is acting at an angle theta, I can replace the force with two forces. Okay, one will be the x component, that is F cos theta, and one will be the y component, that is F sin theta. You have read vectors, so we know that the addition of these two vectors will give rise to this vector. Okay, so that means this, if I write the force in this form or this form, these two are equivalent. Okay, so that means if I just now write if I just now draw the free force diagram of mass m, what will be the free force diagram of mass m? Okay, so mass m, previously we did that the contact forces was N1 upward, mg was acting downward, okay, a force F was acting downward, right? And there was this force, right? F acting at an angle theta, right? That means this force. So this can be resolved with the help of this into this, right? So that means I can write this as F cos theta in this direction and F sin theta in this direction. Okay, so this will be the net free force diagram, or the simplified free force diagram of mass m. Okay, this is the simplified version. Okay, I want you to know this. Okay, that's why I just divided the forces. Okay, so that means we have got the free force diagram of the block of mass m. And now what is the free force diagram of the ground? Nothing but N1 is acting downwards, right? So that means the free force diagram of the ground will be, so this is the ground, and the force N1 is acting downwards, right? So that means this will be our free force diagram of ground. Okay, so I hope you got the video. I just made this concepts to be very clear that a force can be resolved into two components, what is the y component and the x component, and the vector sum of these two, which we have read in vectors. We'll cover it as soon as possible also. What will happen when you will vector add these two? Will get this only. So this and these two are equivalent, right? And it is preferable to draw the simplified version of the free force diagram in your exams. Okay, so I hope you got this video, and we'll be coming with more and more examples and more concepts of free force diagram. We have completed only a few topics on free force diagram. There is a vast syllabus also, so we'll be completing that. We'll be uploading every day a single video on your IB syllabus. So do subscribe, hit the bell icon, stay safe, and thank you for watching this video. Bye.